Now we'll try to understand how to set all the boundary conditions for the airfoil and how to run the simulation. So we already have the mesh ready. So what I did, I imported the mesh here, and you can see it is updated. So now what I will do, I will just right click, I'll click on edit, or you can simply double click on that. If you do it, then you'll get a Fluent window like this. So you need to just click on the double precisions. So just make sure that you need to do it, and you can click this one, the display mesh after reading, or it's up to you. Here I am using this number of processes and the GPUs per machine, but it is not important for you. Just you simply keep as it is. Maybe it will be just one here, it will be 0. So keep as it is and click on stat. If I do that, then I'll get the Fluent. It's actually working. Yeah, you can see it. This is up all the mesh informations. This is called the console at the bottom. Okay, this is our geometry. You can see I'm just rotating like this. All right, so I will try to explain step by step. And this is, this setup, you will find this is same for all the versions. So basically for this tutorial, I'm using 2020 R2. So if you use 19 or 2021, you will see it is similar. I'll click on general at first. So you can see here. So, okay, basically we actually, okay, just let me select from here. If you are using other versions, then what you need to do is you need to double click. But here, I just right click on that. And when I right click on that, then I can select whether it is a steady or the transient flow. So you know for a steady means it is not related with the time, and you know the transient means. So for first case, we'll learn how to run the steady simulations. So it's already selected steady. Now I'll right click again. So what types of solver? This is a pressure based solver. So we'll have the pressure outlet. So I'll keep it like this. The velocity formulation, keep this as it is. The gravity here is, we will keep this on is off. For some other problem, we need to consider the gravity. Here, I'm not considering for this steady simulations. And the other thing, keep as it is. You don't need to think about all the setups. So now click on the models. Here you will see a lot of different models. So you don't need to think about it. We say this is the steady simulation. So we need to set the viscous model. You look at the energy equations, multi-phase flow, a lot of other equations, other models. So click on this viscous model. If you click on this viscous model, you will see a lot of model. We have the laminar and the turbulent model. You see the inviscid model, the laminar model. This is all the turbulence model, right? So what is actually happening here is we will click on the laminar model because, as I mentioned earlier, we're going to simulate the steady laminar flow. So let's select the laminar. If you click on OK, then we already selected the laminar model, right? So now what we'll do, we do not need to think about this discrete phase. This is basically the discrete phase mean this is for particles. So I will just now go to the materials. So what's the materials we have for our simulations? We have the fluid domain, you know, basically we have this fluid domain, we have the solid airfoil here. our material is air, and the air will go through this way. This is our inlet. So I'll click on, or you can click on this plus sign. So you see the fluid is air. Now, if you double click on that, this is the properties. Like if you want, you can use these properties, or if you want, you can change it. If you want to change it, let's say it is 1.2 to 5. So if you want to change it, let's say it is 1.3, you need to click on change or create. So then it will change the value. If you are trying to use some other materials, so this is the Fluent database. If you click on the Fluent database, you look here, this is different types of fluids. Oops. If you just scroll down, you'll see a lot of fluids. If you need solid, so here you see different types of solids. So we'll close that one. There are different databases, or if you don't have the materials here, then what you can do is you can create your own materials. This is the user-defined database. You can import your own database here, or you can use some the user-defined function, some database for your materials. So we changed that. If you want, you can change the viscosity as well. This viscosity, you look here, there are a lot of options. Like you can different laws, like how you can define your viscosity. But for this problem, we're going to consider a constant viscosity throughout the simulation. So I'll close this. Now, okay, what will be the solid? Just double click on that. The solid here, we say this is the aluminum. Just keep it as it is. The Selgen conditions. Selgen condition is, we'll see, we have the body where it is a fluid domain. In some cases, basically by default, this is air. But let's say you have the materials, you change the materials to water or any other materials. So then you must need to make sure that, okay, you're changing the materials here as well. So we have only one materials, the fluid, this is air. So we don't need to change it at this position. So when it is in the cell joints. But if you already have different materials, then you might, let's say water, you have the materials water, but by default, you will see the material is air in this case. There are a lot of options. This is for the cell joints. In this case, we are not considering any dynamic movement of the mesh. So that's why we didn't, we actually don't think about all these options. There are some different pores, joint mesh motions, frame motions, different things. So we'll gradually learn that one. For first projects, we don't need to know that. So we have done with the materials. Now the boundary conditions. Here we have 4 types of boundary conditions: inlet, outlets, wall, and the internal body. That means that's the interior. Now if we double click on inlet, here you see we need to say what's the velocity. So we say the velocity specification method is velocity magnitude, and it will act through the normal to boundary. Like kind of, it's what's the normal definitions. So if I say the velocity is 10 meters per second, just for example, at inlet, and the initial gas pressure is 0, I'll click just apply, and I'll close it. Right, then the internal, this is the interior. You don't need to do anything with that, okay? So you don't need to do anything with that. Outlet, so it'll be pressure outlet. Double click on that. So we'll use the gas pressure. That's the backflow reference frame is absolute. Here you will see, if you click here, we have 2 different types of options, but we'll use this absolute option here. White says it is on 3 to 5. This is the gas pressure. It's given maybe in your questions. If you want to prevent the reverse flow, you can click here, like the prevent reverse flow. There are a lot of other options. If you want, then you can click on this help. You'll be able to see. But for the first problem, I'll try to keep it as simple as possible. So I'll click on apply. I'll close it. The wall, we have the airfoil. This is, I'll click on that. You see, this is the stationary wall. All right. Yeah, so this is the stationary wall. If it is the moving wall, then you need to select the moving wall from here. No sleep conditions. So everything will be as it is. You don't need to change it, anything from here. So this is for the airfoil because the airfoil is not moving. And we have the top bottom. The top, we will keep, this is a openings or the wall. So top and the bottom, I'll keep it as it is. I will not change anything. But the front and the back, as it is this similar, we'll consider this is a symmetry. What I will do, I'll just right click here. Okay, I'll click on type. You'll see different types of boundary conditions. So I'll give it as symmetry, and I will just, this is the front and this is the back. So then, oops, let me click on the back, and then I will click on the type, and I will click on the symmetry. So now we have all the boundary conditions ready. So this is the first part of this video, and please go to the second part of the video for the remaining boundary conditions. And you know, in the second part of this video, I'll show you how to run the simulations and when you can stop the simulation.